we're discussing about the WRF model and overview. Right. Now tell me, how many of you have, except one or two, who have read about the WRF model tutorials? Have others also read or not? I don't know. Because some of the things which I am discussing may be too much, elementary, or it may be repetition to those. If all of you or most of you have already read about the WRF model, tell me. Has everybody, or I will ask one by one. You are not telling yourself, then I'll ask one by one. Najmin, तुमने WRF मॉडल के बारे में पढ़ा है कुछ? Najmin, WRF मॉडल के, हाँ जी? ट्यूटोरियल को देखा था थोड़ा सा, but not so familiar. What about विभूति? विभूति?
Yes sir.
WRF मॉडल कभी पढ़ा है आपने?
हाँ सर, WRF तो नहीं पढ़ा, पर WRF गेम थोड़ा देखा था सर। मतलब उसका यूजर गाइड, जो एनवायरमेंटल सेटअप, वो सब मतलब पढ़ा था अच्छे से।
गेम के बारे में?
हाँ
WRF
सर।
model as such, are you confident about the other parts of the WRF model?
No sir.
No. Okay. So Haritasri, I know you have tried something, right?
Sir, I partly read the manual, but not fully.
Not fully. Okay. Rahul, WRF मॉडल के बारे में कुछ पढ़ा?
सर सेम सर, वो थोड़ा बहुत पढ़ा था मैनुअल से, ज्यादा नहीं पढ़ा था सर।
Adira?
Yes sir, I read some about the like for installing, not in detail.
Partially, that means.
Yes.
Right? Only partially. Anish also tried to
Yes.
compile something, that means he had also read something about that, right, Anish?
Yes sir.
Okay. तो मैंने तो compile
सर मैंने ज्यादातर कोर्स
हाँ जी,
वेबसाइट से किया है जो आपने।
हाँ, कंपैरिजन
सर मैंने ज्यादातर जो yes, sir, तो मैंने वो पर्टिकुलर वेबसाइट ने जिसका लिंक प्रोवाइड किया था ना सर, उससे।
अच्छा, okay, so you read from there.
Yes sir.
Okay. Gitesh also was trying to compile something. Avni, what is your status?
Yes sir.
क्या कुछ देखा?
Yes sir. कुछ कुछ बेसिक इंफॉर्मेशन देखी है मैंने।
सिर्फ बेसिक इंफॉर्मेशन देखी है। हमारा तो एक्सरसाइज कितना तुमने किया है कि नहीं किया है, प्रैक्टिकल वाला पार्ट, I don't know. So those things you have to complete. I saw Asma coming. Asma is there? Asma? Or is she again disconnected? So anyway, I'll quickly try to review, and maybe I will skip some of the things which I feel that it is too elementary, or you might have already seen this. Okay. So probably by now you already know. Last time we mentioned that the WRF model is like a numerical laboratory for the atmosphere, in which whatever you have studied about the dynamics and the physics of the atmosphere, everything is applied in terms of the equations, and you can do many types of experiment, numerical experiment. You can do whatever imaginations come to your mind that you can conduct with the WRF model. Okay. You can do the idealized simulations, you can do the real-time forecasting also. So there are so many applications. And as listed here, this is a tool for research to develop and test physical parameterizations, to conduct case studies, research for specific weather events, regional climate studies, coupled chemistry, fire, hydrological applications, data simulation, teaching, modeling, and NWP. Actually, NWP model or NWP as such subject has become very, very popular, I should say, and also appears to be easier after the WRF model has been opened to the community. Because earlier, modeling people used to think is a very tough thing. Now, when this MMY model or WRF model was not available freely online, then NWP was considered to be a very tough subject because it appeared that it contains only equations, complex equations, and how to utilize them, how to solve them. People were not very much confident. But after this has been made and open to the whole scientific community, people have felt this has become very easier, and also easier for the students to learn, easier for the teachers to teach. Okay, the modeling. Then it is a tool for numerical weather prediction. As you know, is used for hindcasting. That means trying to run the model with the data of the past. Suppose you have past 20 years data, like reanalysis data starting from 1979, which NCMRWF has now produced. You can rerun the WRF model in the from the reanalysis data and create a hindcast, okay, which is like running the model based on the observation, okay, past observation. Then real time, of course, that you already know, forecasting for wind, solar, and air quality, etc. These things already been mentioned last time. Okay, now what does WRF model look like to a user? It contains a set of programs, mostly in Fortran and executables. It doesn't have a GUI, okay, graphic user interface. I mean, there are some people, some group have tried to develop GUI, but not really, much used for people who do the NWP operational real-time forecasting, because people prefer to write their own script and run the model rather than running it through the GUI or apps like this. You see the apps. Yeah. So people don't prefer to run WRF model using apps, although some part of it is possible to run through apps. Like you might have heard about the WRF Wizard. Have you heard about the WRF domain wizard?
Yes, sir.
Yeah, domain wizard. Yes.
Yes,
So,
sir.
yeah, domain wizard is more like a apps-based application in which everything you just click through the apps and then you can try to configure the model, run the execute the model and get the results. But that way, what will happen is that you will not learn the proper scripting language, proper programming language, and proper model. That way, you will not learn. Then, as you know, some of you might have already tried that. It is run based on command line mode. Like there are a set of tar files which you have to download and then untar them, then configure, compile the model, run the model, link it with the data sets, okay, and then configure if you want to run the MPI run, like for parallel processing, and then you supply your input files, boundary conditions, and run the model. That's how it is now done, like a command line mode. Everything can be also put into a script file so that it becomes automatic. All these commands which are seen here, after you tar and untar them, everything can be put into a script file and made it automatic. Okay. Then we have got simple graphic tools to use for post processing and plotting purposes. Okay. Then the modeling system programs have many functionalities, like many different ways to run a model by configuring it in different ways, by utilizing different combination of physics, dynamic subsum, nesting, etc. Okay, decisions needed at every time step, like what kind of input data you would like to have, what kind of domain configuration you would like to have, everything is up to you, your choice, model options, etc. Okay, so this flow diagram illustrates in a nutshell about the WRF model. Like you have a set of external data. Okay, the data can be from different sources. All right. Then the data is used in the pre-processing system of the WRF model, like WPS, etc. Ops grid, WPS. Then the mail model is run. You feed the data to the mail model and run the model, and then you get the output which you post-process by different methods. Right. So in the external data sets, you have got the observed data. Observed data you can use if you want to use the observed data and do the data estimation yourself. That also is okay. Or if you want to use the analysis, like the WRF, the NCEP analysis, or the NCMRWF analysis, or the error analysis, that also you can use to initialize the WRF model. And there is a set of terrestrial data required to run the model. This terrestrial data is used when you are configuring the domain. Right? Like in your domain, what kind of mountains are there? Suppose if you are configuring the domain about the Indian region, then obviously you will have the whole Indian region, then you will have many mountains like the Himalayan mountain ranges, and then Western Ghat, and then Eastern Ghat also. All those mountains will be there. So the WRF terrestrial data is a very big file, more than I think 10 GB or so. It contains all terrestrial data of the topography for the whole globe. Okay, and depending when you are configuring your model, then it will pick up the terrestrial data, the topography from the main data file to your domain. Then it also contains other informations of the surface like vegetation cover, right? Land use, land category, right? Those things are also stored because those things are not changing. Of course, land use and land cover can change with season, but otherwise, for a short range, medium range forecast, that doesn't change. And topography also does not change. So most of the data which contained in the terrestrial data file of the WRF, they remain the same. Okay, they don't change. Then the gridded data set which you use to run the model are like NAM North American model. That is again the regional model covering the whole of North America, or the GFS of the NCEP, or RUC rapid update cycle, and an RPA. I mean, there are different data sets which you can use to initialize the model, including the ERA data set, including the NCMRW real analysis set which they have recently produced. So there are the different data sets which can be used to run the model. Okay. So when we are using the observation, if you have your own observations, or even the conventional observations, suppose if you are trying to download directly from the website, the GTS data also available on the website, or any other satellite data, if you want to download and process yourself and run it, that also you can do that. Okay. So in that case, you have to run a program, additional program called OpsGrid. Okay. If you don't want to do that, then it's fine. You can use directly this analysis from the NCEP like GFS or ERA data or NCEP data, and then directly put into the WPS, WRF pre-processing system. Okay. So then, if you are using the observed data, then you have to assimilate it. In that case, you will have to use the WRFDA. Okay. If you are not assimilating the data, then you don't have to go through this step. Then directly from the WPS, in which you have already inserted the initial data, that will be pre-processed, and it will be put into the real, and real will actually make the input files, boundary conditions and input conditions to run the main model, WRF model. Okay. So then this is the WRF model. As I said, as you know, now it has got both options to run idealized cases as well as the ARWF model, which is the main model. Okay. After you have run the model, then you can post-process it by different methods, by using a Vapor tool, which is a tool for three-dimensional representation of the outputs, or NCL, NCAR graphics, or ARW post, which uses the grads, okay, or RIP, which again is based on the NCL, and some other graphic packages also are there like GemPack, etc., which is also a good graphics package used for representing our mountain areas. Okay, GemPack. Then there is a MET evaluation tool to evaluate the results of the WRF model. How good is the result that you can evaluate, compute different skill scores and statistics of your model output. So these are the WRF modules, different modules of the WRF modeling system. Okay. Then, as you know, the WRF pre-processing system. It has got a pre-processing system, and its program flow diagram is here, given here. Like its function is to decode the methodological data, which are stored in the grid format. So there are three components of this. Now, ungrid, geogrid, and metgrid. Okay. The purpose of ungrid is to ungrid the grid data, which are the formats used for storing data file by NSEP or many other centers. Then geogrid, as I said earlier, it tries to process the static data. It doesn't change, like topography, like vegetation cover, the land category, the land use, etc., etc. Those things are all processed by the geogrid. And the metgrid, function of the metgrid is to interpolate the data, because this ungrid is a global data. The data which you download from ERA or from the NSEP reanalysis, that is a global data. So from that global data, it interpolates to your model grid through the metgrid. Okay. So these are the function of the WRF pre-processing system. There are three parts: ungrid data, geogrid, and metgrid. This part is something like it is fixed. Once you do, then that is done once for all. As long as your model domain is fixed, then you don't have to run this part. But ungrid part you will have to run again and again, because every time your data, the methodological data is changing. And also similarly here, metgrid also you have to run every time. If you are making a real-time forecast, for example, then every day you have to run the ungrid, and every day you have to run the metgrid. But you don't have to run the geogrid every day, because it is fixed. They're all static data, it doesn't change with the time. Okay. So after having done that, your job of the preprocessor, preprocessor system, WPS, is complete. Then you come to the model. Okay. And in the model, as you know, again, there are two options. One is for real, another is for the ideal. Okay. And in the real time mode, whatever data is now interpolated, the methodological data onto your grid, that will be again further interpolated in the vertical, according to your vertical levels that you have configured for your domain. This metgrid does only the horizontal interpolation. Okay. The function of the metgrid is to do only the horizontal interpolation. But in this part, the data is also interpolated vertically to fill up all the levels that you have configured in your model. Because you can change just like you can change your resolution, you can also change your vertical levels. Right? So the purpose of this real is to interpolate the data in the vertical levels, vertical sigma levels of the model. Okay. So after having done that, then you fit into the model and integrate it for forecasting purpose in the real time. Okay. So this is the program flow for the WPS and the WRF system. And these are some basic concepts you already know. What is the basis of making the model forecast? You already know these things like dA by dt equal to FA, some forcing term. Okay, rate of change of A, any variable with time is equal to some forcing function. Okay, and then you integrate this with time, delta t, and then you get a forecast for the next time. A forecast is equal to initial condition plus the FA, the forcing times the delta t. And this is for the just fundamental review. And this also you are familiar with how the data is represented. Like this is the grid, and the data is arranged at all the grid points of the model. And this is just an analysis shown out of this grid data. You can make the smooth analysis, okay, which is continuous line, iso lines for the variables, whatever you are trying to analyze. So then LAM, the limited area model. Okay, LAM is, as the name suggests, it is a limited area. This is a global domain, for example, of the model. But from this global domain, whatever data you are getting from the NSEP or ERA analysis, that is for the whole globe. But from this globe, you can run the model for your domain of interest, for example, over the Indian region, okay, which is a limited area. Okay. So in this, the illustration is given for the USA, North America. Okay. And then domain is configured for the North American region. There is a LAM, limited area model here. Okay, and these are the illustrations for your lateral boundary conditions, etc. For example, this indicates that different levels are there in the model: level 1, level 2, level 3, and so on. And this is top of the model level. This is the boundary, bottom boundary. This is the top boundary. Okay. So if you are configuring the regional model, then you have to provide the lateral boundary conditions and also the top boundary conditions and the bottom boundary conditions, right? And if you are using a nested domain, then automatically from the outer nest, the boundary conditions are provided to the inner nest. All right. So this is the global domain, and these are the limited area domain. And this is the illustration for nesting. Like you have got this is a global domain, out of which you have got a limited area model like this, and inside that you have got another nest which is blown up here. Then inside this nest there is another domain which is blown up there. Again inside this there is another nest which is blown up here. So you can have multiple levels of nesting. Okay. In fact, within one parent domain, you can have one nested domain here, another nested domain there also. So all these things can be done to optimize your computer timing, and at the same time run your model at a higher resolution over the area of your interest. And why do we do nesting? Because if we want to run the whole globe at a high resolution, then it will become very expensive. So we cannot afford, most of the people cannot afford to run on their computer the whole global model. Therefore, the nesting is done so that you can run at a higher resolution in the area of your interest. And because of nesting, if you are going higher and higher resolution, you can represent the data more and more accurately. For example, say these data are shown at 3 different nesting. This is shown at the 30 kilometer resolution. This is shown at the 10 kilometer resolution, and this is shown at the 1 kilometer resolution. So if you are using a 30 kilometer domain resolution, then this is how your topography will look like. If you are increasing your resolution to 10 kilometer, then your topography will increase like this. If you are further increasing to 1 kilometer, then your topography will look like this. Okay. Similarly, your land use, land cover data also will show more and more finer features when you are increasing the resolution. Okay. So this is three-dimensional view of the WRF model. You might be familiar with this diagram. Okay. This shows different layers of the model. Okay. And depending upon what coordinate system you are using, whether you are using a jet coordinate system or pressure coordinate system, vertical levels, how many levels you are configuring, what kind of parameterizations you are opting or using, those things are all illustrated in this diagram. Okay. Then what will you learn from this tutorial? Well, this will teach you how to configure your domains, how to place different nests, and also process your GeoGrid data set, that is fixed data set, how to process the WPS system, your met data set, etc. This is what is taught in this tutorial. Then preparation of data for initial and boundary condition. Okay. Now, as I said, you have a set of meteorological data obtained from different sources like ERA or encephalasis, etc., which is in the GRIP format. So it has to be ungripped using the ungripped.exe file. Now, this file, this executable will be generated when you successfully compile the WPS model. Then I've got G data, which is the fixed geographical data sets. Okay, geogrid.exe will do that, and then it will produce different files called geo_em for different domains, domain 1, domain 2, domain 3, etc. Okay, then you've got the intermediate files generated based upon the meteorological data which you try to collect from the ERA, etc. After ungripping, you pass your data through the metgrid, and it will interpolate the global data into ungripped form onto the model grid. Okay, and you will get an output like met.em now for domain 1, domain 2, domain 3, etc. with the data stub. And then pass on the data to real.exe, which will vertically interpret the data. And finally, that will pass on to the, this will convert, or this will prepare three different files. Like if you are using the data assimilation, then this will prepare a file for the data assimilation, WRF DDA. If you are not using data assimilation, then it will just prepare a boundary file, WRF boundary, or if you are using the, and also the WRF input for the methodological data interpolated onto your grid system. And then these things are used for running the model, WRF.exe. Okay, so these are the ways the WRF model system prepares the initial and boundary conditions. And then you run the model by integrating it. Okay, and you know already these things. Now we have studied that now the model, internal structure of the model contains all these equations, which are equations governing the atmosphere momentum equation and all these equations. Okay, then there are a set of numerics to solve those partial differential equations at each grid point. So those also you have studied earlier, the numerics part, and then you have also a set of physics. Different options are available. You can choose your own physics options, and that is set or fixed for your model configuration. Then based upon that, you run the model using a computer. Okay, if you are running a complex model, then you have to have a very big computer, massive computer like this now shown here. Supercomputer, so-called supercomputer, or HPF, high performance computing system. Or if you are running a small application, then you can also run a workstation or even on a PC also, or even on the laptop also. Then after your model is run, then you can post-process the result by different methods, which we discussed in earlier slides, and then get your outputs in different formats. If it is a paper, then you will see your output in the three-dimensional form like this. If it is a NCL, then you can see the graphics in two-dimensional form, or graphs, then you will see the outputs in the two-dimensional form. And of course, there are different ways to compile the system that we shall discuss maybe in another class. Okay, so well, these things are just clear how to, it's quite clear if you just read yourself. So I think that's it about the overview of the WRF system. Okay. So this is just now a popular slide which you can just read yourself and learn it. Okay. So this completes the overview of the WRF modeling system. And let me see how much, what is the time now is. Our class, right? 3:30 our class?
Yes, sir.
Yes, sir.
Okay, so another 10 minutes, I'll just start the physics part also. Okay. And let me start the physics part. Is that okay? Overview of physics. Have you seen this file here? WRF overview of physics. Yes or no?
No, sir.
No, sir.
No. Okay. So this file gives an overview of the physical processes used in the WRF model. I have not changed nothing in the original tutorial file which was made by Jimmy Dudia, okay, at Ankar. This was made and presented also in January 2020 tutorial. Okay, a very big file. You can see that the 133 slides in this overview of the whole entire physics of the WRF model. We shall try to just see this file, not slide by slide. We skip some of the slides because you can also read yourself to get an exposure to or to learn yourself. But just important slides we shall just try to discuss something today and also something maybe tomorrow. Because today we have got only 10 minutes left. Okay, so in this WRF physics, as you know, there are different physical processes. One is the radiation. Let me put in the slideshow mode. Radiation, which has got two parts. Now, one for the long wave and one for the short wave. And this is the variable used for selecting the option of the physics. Like radiation, RA stands for radiation, long wave, LW, physics. And similarly, radiation, short wave, physics. So different options are available for this, which are discussed now, just for your exposure. Details you can read yourself. Then the surface processes, okay. Surface processes that you have already studied also earlier, the land surface processes, parameterization schemes. There are different parameterization schemes available for that, and also your surface layer physics. You know, surface layer, right? What is the surface layer? What is the depth of the surface layer?
The lowest part of
Yes,
PBL,
exactly.
100 meters.
Yeah. The lowest 10% of the PBL is generally called the surface layer. So what kind of physics now you choose or you use, that is available in this part of the physics, and this is controlled by this option: SF surface physics, SF sea layer physics. Okay, and there's many options we shall see later on. The land surface schemes, land water surface scheme. Here also different types of land surface scheme like NOAA or 4-layer model, 5-layer model, or RUC, etc. They are available in this. We shall discuss maybe in next class. And there are so many PVL options available for the planetary boundary layer. And this is the name of the variable which controls the different PVL options. Then turbulent diffusion option is controlled by these two parameters, diff opt and km opt. Then cumulus parameterization, convection, etc. This we have studied earlier, and this is controlled by this option, CU physics. Many options are available. As you have studied, like for the core type scheme or recover type scheme or simplified recover type scheme, Kane pressure scheme, or relaxed recover scheme, etc. Grail scheme. All these things options are available in this physics option by different choosing different options numbers. Then this is microphysics, MP physics. Okay, and this tells you what microphysics to use, how many species of the hydrometeors you want to consider, whether you want to have a simple microphysics or a very complex microphysics. All these things are decided by choosing this MP physics option. Okay, so this is a flow diagram which shows the complex interactions between different physical processes available in the WRF model. Okay, like the main physics, as you already know, radiation. Okay, both short wave and long wave. It reaches the surface through the passing through the atmosphere. Okay, then you have got the land surface scheme. Okay, surface latent heat, sensible heat, emission from the surface, albedo, etc., which feedbacks to radiation. Then your planetary boundary layer, which compute the tendencies for the T, QB, etc. in the PBL. Then you have the cumulus convection scheme or cumulus parameterization scheme, which compute the rainfall and also compute the impact of the convective clouds onto the environment, that is cumulus warming, drying, etc. Okay, and then it also provides an input for the cloud microphysics in terms of the amount of mass retrained from the top of the cumulus cloud, which goes as an input to the cloud microphysics. Okay, then it also is used to compute the cloud mass fraction or cloud amount, which is used for the radiation. The microphysics, it has got also the computation of the non-convective rain. Convective rain is computed from here. The non-convective rain or the large-scale precipitation is computed in this part, and also different cloud effects, which is used for the radiation purpose. So this is just a overall broad flow diagram of the WRF physics and the interaction between them. All right. So I think today we shall stop here, and tomorrow we shall try to complete the rest of the physics if possible. Although you have seen 133 slides, so it may not be possible to discuss all the slides by tomorrow. But I may skip some of them. You can read those slides yourself to get an overall overview of the whole WRF physical processes, parameterizations. Okay. So let me stop here. Is that okay, everybody?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
10 people are here. Do you think discussing these slides are good? Are these useful to you? Or you can read yourself also, that is fine for me. If I am discussing these slides in the class, do you think that it is better to discuss so that it will be helpful to you or more easier to understand for you when you are reading the slides yourself? What is your opinion? Tell me. Is it
सर एक
useful?
क्वेश्चन है
Yeah, question है बताओ.
सर जैसा आपने बताया कि इसमें डाटा एसिमुलेशन वाला पार्ट नहीं होता, जैसे हम लोग ग्रिड डाटा डाउनलोड कर देते हैं एनसेप से और ECMRWF से और फिर हम उसको WRF में कर लेते हैं, लेकिन अगर हम ऑब्जर्वेशंस खुद लें कैंपस के अंदर, अगर हम इंस्ट्रूमेंट करके ऑब्जर्वेशन लें और उस ऑब्जर्वेशन की जो वैल्यूज है उसको अगर हम ग्रेडेड फॉर्म में कन्वर्ट करें और फिर उसको अगर हम एसिमुलेट करें, मतलब एसिमुलेट करके और फिर हम इसे रन करें WRF में, तो सर उसके लिए आपने एक सॉफ्टवेयर इसमें बताया WPS DA करके बताया सर आपने कुछ.
वो एक अलग पार्ट है क्योंकि सबके पास ऑब्जर्वेशन नहीं होता है. Everybody does not have their own observation or everybody may not be interested in data assimilation, right? Therefore, that is made a separate module called WRF data assimilation. So that is optional. If you want to do the data assimilation, if you have your own data or you want to download your own data from the net, from the for the satellites or any other observation source and run the model, then you can do so. And for that, the model is separate called WRF DA. Okay, but many people actually, I tell you, about maybe 80 to 90% of the people do not do the data assimilation themselves. They just like to run the model by using the re-analysis data, the graded data from either the NCAR, NCEP, or from the ERA, or from any other source. And that's why this is a separate part which is done through the WPS. Okay. Lekin certainly WRFDA is very important, which everybody should learn because you would like to assimilate your own data. And at every numerical weather prediction center, like NCMRWF or NCEP or ECMWF, this part is not done. This part is very, very important. For real-time numerical weather prediction, is always good to do the assimilation by yourself. Although it's not necessary. I mean, you can assume that whatever assimilation has been done by NCMRWF or ERA, that is okay for you, and you don't have to input or ingest any new data from your side, and it's fine. So, इसके लिए अलग module बनाया गया है. We can discuss that part also. If you want to, after discussing these modules, basic modules, then we can discuss that module. Okay.
Okay, sir.
Right. So, any other points to discuss? So, I was asking that whether I should just make an overview presentation of all the WRF models so that it will be easier for you to understand, or you can read the slides yourself, all the slides. What is your opinion? Is it beneficial to discuss these slides in the class? Useful or not useful?
Yes, sir.
Okay.
It is
Sir,
useful.
useful.
Okay, very good. So that's why I thought that I should give you exposure so that you can go back and see the slides yourself and then learn it further, more deeper. And then you can ask questions if you have any questions after that. Right? But then definitely we shall try to discuss an overview of all the slides here in the class. Maybe in the next 2 or 3 classes, and hopefully by this week try to finish this part. Okay. At least the whole of the WRF modeling system, the basic, including the physics and the compilation options, and then after that we can go on to the WRF DA. Also, that probably is not possible in this week. That we'll have to do in the next week. Okay, if you want to continue the class next week also, then we can discuss the next week, the WRF DA part. And other parts, it depends upon persons to persons interest. Like WRF Chem, we are not going to discuss here, chemistry part, because those who work on the chemistry, there are very few people who work on the chemistry, and it is only of their interest. They have to learn themselves, read and learn. But once you have learned the basic part, fundamental part of the WRF model, those things you can learn yourself also, like WRF Chem for the chemistry, WRF Hydro for the hydrology part, flood forecasting, etc., or WRF CLIM for the climate runs, and many options like that. Okay. So that's it for today, and I'm going to stop the presentation. Okay, and then I'm going to stop recording also. So today's recording is going to Abira.